Good evening, ladies and gentlemen. It's a pleasure to be here this evening presenting what we are building at Clipre.AI at Ruvision Thinking Labs. I am Dr. Hiteshri Shastri, co-founder and CTO at Ruvision Ventures Private Limited. I am leading a cross-functional team of researchers at Ruvision that sits at intersection of climate scientists and AI researchers. So our solution goes as like this. We are trying to build a weather climate intelligence system, a digital public infrastructure system for India. And it sits at the intersection of science and AI. Sounds a little complex, but then don't worry, I'll make it simple going further. So I did my PhD at IIT Bombay, wherein my research focused on hyperlocal weather modeling for urban India. And that is from where genesis of this solution came to me. So what we are trying to do is bring the best of the science into application and industry scale to the national scale. We are building climate intelligence system, which stays the intersection of AI and physical science. So our goal is simple, but then as well as very ambitious. We are, set to build a system which is built in Bharat, for Bharat, and scalable and exportable to the world. So how does that go? It goes like this. If you just see the slide, here what we are talking is actually not a weather and climate problem. It is an infrastructure problem. And at this point in time, let us also realize that India has started taking infrastructure as digital national system. Let us think of identity in form of Aadhaar that has become a horizontal layer, or UPI in terms of the fintech digital infrastructure layer. When these layers existed, there came a new system of innovations on top of it. An entire ecosystem flourished in fintech and digital identity. So what we want to talk in here is next, weather becomes an operational infrastructure. How does it go? Sounds strange? Yes, but then not really that strange. Weather information do exist at this time, but then at the same time, it remains fragmented, averaged, and detached from real-time decision-making. So what is this condition that I'm talking about? Urban systems, they don't receive real-time flood warning systems. Farmers don't know how to protect their crop in terms of adverse weather conditions, or say the heat stresses that occurs over the city. It doesn't translate in terms of what is going to be the next increase in energy demand. And disaster, it remains more reactive and not proactive how it should be. The gap that we are talking about is enormous. Consider the urban floods. We all must have seen in news, if not in real. Consider the crop losses and 50,000 crores of disaster losses occurring every year. So this is the gap that we are trying to address in here in terms of a horizontal layer of weather and climate intelligence. So talking a lot about the problem, going to our solution, we are building Clipre.AI, which is what we call NCIS, National Climate Intelligence System. What it is, it has multiple modules such as hyperlocal weather forecasting, impact prediction AI, multi-hazard early warning, climate system intelligence, and digital climate twins. All of them remains a plugin wherein the government and independent identities can plug in for the data to flow to their system to bring the climate resilience information into their system. So let me try and draw a parallel to this. How UPI created a complete this fintech innovation. That is what we are talking about here in terms of weather and climate intelligence, a horizontal layer. A DPI, digital public infrastructure, made with climate. And I mean, that is what our solution is all about. So how we are building it, this is how we build it. At the heart and core of the system remains physics-informed AI. What is physics-informed AI? Weather prediction is all the climate dynamics, what we studied in our physics, temperature, wind, sun, right? And then it goes on. So then that is robust and proven physics models which work and gives prediction. But then at the same time, these models are computationally very heavy. They are very slow, difficult to scale. On the other hand, remains AI models which are quite swift, but then they lack the scientific grounding. They are just data-driven. So climate scientists are kind of, rejecting or not very convinced when you bring just AI and no physics into picture. So what we are trying to do is infuse physics and AI to make scalable, robust models that work at hyperlocal scale and are reducing the cost of per forecast cost at a good level. So that is our solution. We inject a lot of real-time data to make it more robust in terms of time, say satellite data, radar, ground observations, terrain, all whatnot. On top of it remains our impact layer. So you estimated the condition, how it translates in terms of ground condition. So say you have some extreme weather, so there is a stress to the energy system, urban system, infrastructure system. The stress estimation is our next layer. And the last is intelligence. So the system is not static, built in once, keeps on functioning. No, what we are building is the self-improvising system with lot of features which iterates it whenever it deviates from the real ground scenarios. So that is our solution. And so why we are here and what is our ask? I mean, our approach is, validate, do a pilot, and scale. So when we are talking about weather as an infrastructure, I mean, credibility and, the reliability is non-negotiable. Again, trust is to be engineered and not to be, commanded or to be just imposed. So we need a lot of validation. We want organizations, agencies to validate and use our models that will bring more and more credibility to this system of modeling. At the same time, we also need to do a lot many pilots to make the system test in the real scenarios so that, we can estimate what is the cost saving or what is the operational ease erased in there and all whatnot. And the third is a scalable. So any proven system can be put into multi-city pilots or at scale plugged into the disaster control rooms, agricultural, large-scale forecasting, adoption systems, and all. So this is our ask. And we are not building a product in isolation as a team. We are just co-creating what we call NCSI, National Climate Digital Infrastructure, and the partnerships in this room will determine how this will shape further in Resilient India. Request to please play the video. We have a short demo of our working pilot here. So thank you very much.